here. All right, so we built this out, and I'm just going to introduce what this does. This algorithm um, works by really what we're doing behind the scenes is we're going through this note that we like want to build, and for each character, looking through the magazine, seeing if that character exists, and if that does, cutting it out of the magazine so we can't find it again, right? And we do that for every character in the note, either until we get to the end of the note or until we find a letter in the note that doesn't exist in the magazine. If we find a letter that doesn't exist in the magazine, we return false. If we don't, we can just return true at the end. We've looked through the magazine for all of these. First off, we had a couple of things that here that I don't think are really necessary, like this hypothetical array we didn't actually end up using. So I'm going to kill this real quick. And I think this still works, right? We can run the RSpec again. And this all works. Some things in terms of the code that might not be exactly clear. We're going through before we even feed our characters into like this, like to actually get the syntax done. First thing we're doing is we're making sure that all of the strings we're passing in are lowercase. We don't want to have to worry about capitalization here. And then we're using this G sub right here to get rid of anything that's not a number or a letter, because we don't need to worry about spaces and we don't need to worry about punctuation. So it shouldn't be in our array, right? We shouldn't be looking for it. It may be that you only need to do this in note characters, right? But the more we can get rid of items, the better. And then we are turning this string of magazine characters into an array. And we're doing the same for note characters, right? So in this case, right, we are iterating through each one of the characters in the note. And for each of them, we're checking to see if they exist in the array. And we're not just checking to see if they exist in the array. We're also at the same time being like, hey, if you find it in the array, give me the index. Because if we can find the index at that place, we can use this delete at method to pull it from the magazine array so that we can't use it again. So that avoids the situation where we're trying to write cheese and our magazine only has 2 E's, by just making sure that that E gets deleted. If we can't find the index at any time, we can just return false. Cool. And so that's how this method currently works. And it's one way of building things out. We've determined that this is quadratic, right? This would be an initial solve to this. And the reason why it's quadratic, right, is actually because we're doing a loop inside of a loop. For each character in the note, we're going to the magazine and we're looking through the entire magazine array. And then we're doing that again for each time. So every time we add a character to the note, we're going through the magazine another time. So that's n squared. So this is a great first solution. I would propose that if I were given this problem, there is a way to make this linear. And of course there is, because I built this out to teach this, right? If I were given a note in a magazine, right? I could really quickly build out a little tally on like a notepad or something, where I just have a list A B C D E F G H I J K L M N O P Q R X T. You know what the alphabet looks like. And I would have a little tally next to each of those. I would go through the magazine, right? I'd go, every time I saw an A, I would mark a tally next to it. Every time I saw a B, I would mark a tally next to that. And I would count up the number of characters in total, the number of each character in total in the magazine. Then I could go through the note, right? And every time I saw an A, I would delete that one from the tally. I could keep doing that, right? Until I either found a situation where I had more characters in the note than the tally, or until I determined that I was out of characters. And this would be how I would build out this solve, right? So first off, there's a couple of pieces of reusable code that we can use here. I'm going to go ahead and I'm going to say def right here. And this right here, I'm just going to copy this. I think we're going to end up needing to do this exact same thing again, right? Now, at this point, I'm going to start typing out my ransom notable. So we can comment this really quickly, unless you want to keep typing on it. Def ransom notable. Magazine note. And here, right, the first thing we're going to do is we need to create this little tally, right? Which is going to basically, um, which is going to basically uh, take in this magazine and turn it into a hash of characters. And that is something I love the single responsibility principle when I'm developing. So that sounds like it could be its own method, right? Like we want to take like an array and turn it into a hash. So I'm going to go ahead and do that. I'm going to go ahead and say array of characters to hash, or characters to hash, I think makes sense, because array of you can usually just infer from this S. Cool. And here, I'm just going to go through it. I'm going to start with like this little hash right here. I'm going to go through the array. And I'm going to say, hey, is there already a character in a key of A in this hash, right? If there is, add 1 to its tally. But if there's not, give it 1, right? And now I'm just going to go ahead and I'm going to return that hash. Or we can just do this, right? This is called sandwiching. There's usually an easier way to do it. I bet we can do it with a reduce. And for now, I'm just going to comment this out, and we're going to test this code out really quickly to see if everything works the way I kind of want it to. So I'm going to comment in this pry. We're going to run our code. Oops. I'm going to comment in require pry. And now right here, I'm going to do characters to hash. And then I'm going to pass in string to lowercase letters magazine. And now we get this neat hash of all of our characters. And a hash is great because a hash has a constant time lookup. So now we've gone through this magazine, right? And we've just gone through it one time. We've only, like this right here, you can see it's 1 each, right? And that's all we need to do to store all of the information about our magazine. And then whenever we want to look up an item in that, that's going to be a constant time lookup. So that's not going to add to our time complexity. So now that we've got that, we can go ahead and we can make this work, right? We can go ahead and say characters or character hash equals characters to hash string to lowercase letters magazine. Cool. And then the next thing to do would be to go through string to lowercase letters note that each do character if hash out a key of character and if it's greater than 0, right? So if there's still 1 or more remaining, hash character equals hash character minus 1. And there's neater ways to write this. We can turn this into fewer letters. But this is really all we need to do right here. And so what this is going to do is it's going to, for each of the characters, it's going to, like the first time it sees a U, it's going to remove a U from this hash, right? We can even we can actually go ahead and take a look right here. If you want to see your dollars again, we see this I, right? So we want to turn this I to a 15. F, we want to turn it to, unfortunately, a computer is much easier at looking this up than I am. F1, right? But if we didn't have an F here, if the F was 0 or if it didn't exist, right, we would want to return false, right? We haven't found it. But if it goes through the entire thing, deleting and it goes through it and doesn't find a situation where it can't find a character in that hash and have it be more than 0, that's when we return false. So if we run our RSpec again, commenting out this other ransom notable that works, right? It still like worked very efficiently, right? Oops. We can go ahead. And I think I just got failed to connect here. I'm just going to go ahead and say RSpec when I regain a connection to REPL, and it should work. In the meantime, do we have does anyone have any questions on how this works?
I would have never thought about doing this solution.
Yeah.
That's intimidating.
Whoops. It's one of those things where it becomes way more way easier to remember to do that when you just remember okay, is there a way I can solve this with a hash? Which is kind of the wrong way to go about solving the algorithms, right? But oops. But eventually, as you do more algorithms, you start to learn about this specific character's hash data structure, which I've currently broken. Oh, if character hash. Oops. Eventually, this, I've written this exact line in to solve so many different algorithms. It is really helpful of just turning something into a hash so you can look it up really quickly. So this was something that was kind of straightforward for me because I've used this solution to solve a lot of different problems before. Eventually, you just want to take an array and throw it into a hash. Sometimes it's one of the most comfortable data structures that there are, and it makes things very quick to look up. When I use the tally marks example, it really is helpful sometimes when you're thinking of an algorithm to just try to imagine a way to do it, a couple of different ways you would do this in real life. But overall, I think if you got to this point, that's great, because this is a really difficult algorithm that I want to throw out early to reinforce the concept that using a hash makes things a little bit simpler, or is a good way to refactor things. Because really all we're doing here, right, with ransom notable is the exact same thing using an array, or with the other one is the exact same thing using an array. We're going through the array, we're removing the item, and then we keep doing that until we can't remove anymore. In this case, we're using a hash and we're just keeping track of it with a number. The only thing that really changes here is the data structure.
So I just want to talk about line 28 to 29. Can you explain what's going on there again?
Yeah. So first things first, we want to check, hey, is there a U at all, right? because I can't go ahead and call like on line 28. I can't go ahead and say like, hey, are you greater than 0 if it's nil, right? I don't want to end up in a situation where this turns into nil, right? Because then I get an error. If I do this, I think this might error out. I might be wrong, or I might not have a test that checks that. So yeah, in this situation, right? Undefined method greater than for nil class, right? It looks for um it looks for a C and can't find it here. And since it can't find it, character hash at a key of C is going to be nil, and nil isn't greater than 0. Nil is nil and doesn't have a greater than method. Whoops, what did I just break?
So character hash at the index of character, that's
Let's just go ahead.
like what? That's the count.
Yeah, it's going to return the count, right? Or it's going to return nil if it can't find that character at all. So if it has never seen that character in the magazine, it's going to return nil. Otherwise, it's probably going to return like 0, 1, 5. And we want to return a number greater than 0. Because if it returns 0, that means we've already used that character.
Why are you checking for it twice?
In this case, right? The first case we're just checking to see if it exists. The second case we're checking to see if it's greater than 0. And the reason for that is because otherwise Ruby is going to error out here if it doesn't exist.
Okay. Huh. I also have a question about something in the old code.
Yeah.
Let me comment that out.
I can get it.
So line 43, when you're iterating, note characters, and then you're checking it at the index. I mean, checking the magazine characters array at the index of the note character. Can you explain what that's doing?
So index returns either like the index of the item in the array, right? Or it's going to return nil. So if we have let's say B, C, these are all strings. Then we r dot index B will return 1. R dot index D will return no, right? So this actually works really well to both be an include method. Hey, does this exist in the array at all, right? If the index exists at all, right? Then we've got a then this works, right? Or then like we found it somewhere. If it doesn't exist, then we return false. And then the next step is we have this delete at method, which is just used to delete an item in an array at an index.
So the return value is like line 46 or line 47, and that's where it's going to be deleted at that value.
Yeah. So if we want to delete B, this is kind of one way to do it. There's probably a better array method. This is the way that I usually delete an item from an array after finding it. So this goes find B in the array, and then delete it at that index. Make sense?
Okay. Yes, thank you.
Cool. All right. Well, thank you for being the guinea pig here. And probably everyone watching at home, good job of whatever you did.